I'm going to talk about data-oriented techniques in the BABOK guide. I'll just introduce myself. I'm Nick de Voil. I'm a consultant, business analyst. I'm also a trainer. I train people in for the IIBA exams, the CBAP and ECBA. I also train people for other business analysis certifications like the BCS ones and the IIBA requirements engineering exam. There's a book that I've written there, User Experience Foundation. So I'm very interested in user experience as well as business analysis. I've been in IT for 37 years, working mostly in investment banks and other financial institutions, with public sector organizations in the UK, and also with quite a few internet startups as well. I've been a member of IIBA since 2009. And for a lot of that time, I've been on the board of the IIBA UK chapter. I was doing that for 8 years, and I was the joint president for 2 years. I've got several IIBA certifications, but I'm also a certified data management practitioner, which is quite relevant today, and a certified management consultant. So data, why are we talking about data? It's a couple of reasons. One is that in the BABOK guide, there are several techniques relating to data that are mentioned. There are only 50 techniques in the BABOK guide, but at least 4 of them are related to data. And my experience when I've been training people is that they are scared of them. They're scared of doing things to do with data. I don't really know why that is. It comes across as technical and difficult to people. When I showed my slides to Michele, he said, "Well, don't say anything too technical." So I will try not to say anything too technical, but understanding data and the techniques associated with it are quite valuable. Judy was saying earlier this afternoon that it's a very sought after skill she finds in her recruitment work, which was interesting to me. But organizations need to care about data as well. You've probably seen this picture before. Data is little atoms of captured stuff that doesn't necessarily make any sense. But when you start to analyze it, you start to see the difference between things, the commonalities between things, it becomes information. When you see the connections between those pieces of information, it becomes knowledge. When you start to follow the paths along those connections between things, you can achieve the insight that you get from seeing the relationship of the whole to the context, and we can always hope to acquire wisdom at the end. So data is really important for organizations. If you don't understand data, if you don't have a plan for your data as an organization, you're in the dark. There was a very good book published in 1988 by a lady called Shoshana Zuboff. It was really a prophetic book, I think. She said some very interesting things, and she introduced a new word. The word was informate, to informate. And to informate is to turn into information things that weren't previously considered information. And she said, as information is used to reproduce and improve upon substituting machines for human agency, it accomplishes something quite different. It both accomplishes tasks and translates them into information. It produces a voice that symbolically renders events, objects, and processes so that they become visible, knowable, and shareable in a new way. And she wrote that in 1988. And since then, We have social media, which allows organizations to find out what people are thinking on a massive scale. We have things like digital watches and fitness assistants that we can wear on our bodies that will turn aspects of our physical being into data. Everything is data. Our feelings are data. Everything is data. And the way that people interact with each other is data. So every single thing that an organization needs to take into account is data. And if we look at the BA core concept model from the BABOK guide, we can see that data is relevant to a lot of those things. I think we are accustomed to thinking about data in the context of solutions. We think about modeling data, defining data as an aspect of a solution. But of course, the need for that information is an aspect of needs. And when we think about the data that the organization needs, that is the context for the organization. The data describes the context for the organization. And when we think about what is the data, or when our stakeholders think about what the data is, each of our stakeholders is thinking about it from their own perspective. So actually, the stakeholders are very relevant to data as well. So when I talk about data-oriented techniques, I'm not talking about business data analytics. Very often people get confused between business data analytics and business analysis with reference to data. So business data analytics, as referenced in the syllabus for IIBA's CBDA certification, is about analyzing numbers. It's about identifying clear problems, about identifying the numbers that you need in order to solve those problems, and is about analyzing that data to find the results, the solutions to those problems. But what I'm talking about is analyzing all those areas of the core concept model from the point of view of analysis. And thinking about the knowledge areas, data is relevant to many of the knowledge areas as well. Again, we would typically think of data with reference to requirements analysis and design definition, certainly. But thinking about what I've just said about the importance of data to organizations, actually data is important for strategy analysis as well, because the data that you're able to use as an organization, use effectively, is a key capability of your organization. It's a key architectural capability for your organization. And for solution evaluation, it's very useful as well. If you're evaluating third-party software, a very useful technique for doing that effectively is to model the data that is managed by the solution. So data modeling is the best known technique that is in the BABOK guide in relation to data. And there are 3 levels of data modeling that are commonly referred to: conceptual modeling, logical modeling, and physical modeling. The conceptual model is about modeling the business domain in the context. The logical data model is about modeling the information that's needed by a software application or a solution of some sort. And the physical data model is about designing a database. So what I'm going to do is I'm going to show you some examples of models that I've used over the years working with my clients. They're all examples I created in the last 10 or 15 years or so, from different organizations, public sector organizations, banks, etc. And I won't spend too long talking about each of them, but I will just show you how I use these techniques and hopefully make it clear that they're all very similar, but you can use them. The beauty of the data modeling technique is that you can use it for many different purposes in many different contexts. So perhaps we're all reasonably familiar with the idea of a database schema. So this is a physical database model. If we have a relational database system, then that system will store information in tables. Each table will describe some sort of information about the world, and the table will be structured in rows and columns. Each of the columns will have a name, just like in Excel, in an Excel spreadsheet where you might have a column header for your column. And the information in the different tables is related by using fields that can appear in more than, or using columns that can appear in more than one table. And that allows you to navigate from one part of the data to another. So that's a database schema. But the main purpose of a data model, the most important purpose of a data model, is not to design a database, but to describe a business. This is a quotation from Chris Bradley, who has written a lot and talks a lot about data management and data modeling. The main purpose is to describe the business, but it describes the business in a disciplined and structured way, which is exactly what we, as business analysts, we are always trying to do. It describes three main things. Firstly, entities or classes, and these are types of thing that the organization needs to know about. So if I'm running a retail chain, I need to know about my customers. So a customer is an entity. I need to know about my shops. So a shop is an entity. And I need to know about the products that I sell in those shops. So a product is an entity. And secondly, we need to know the attributes about those things. An attribute is a type of fact about one of those things. So a product may have a price, for example. A shop may have a location. And then thirdly, and perhaps most interestingly, associations. So the associations are the potential relationships between instances of those things. So a customer may order a product. There's a relationship between a customer and a product, or there may be. If customer A has ordered product B, then potentially there's a relationship between customer A and product B. And we can show that in our class model diagram. But it's a model of the context, it's a model of the business. So here's an example of a conceptual data model that I drew for a government client. And you can see it's very simple. It's very simple. There are just boxes with a word in each box, and there are lines joining the boxes. So each box is an entity, and the lines represent relationships between them. There is another sort of line that's shown on the diagram, as well as the simple black lines. There are also these blue lines with arrows on them. So the line with an arrow on means this is a sort of this. This is a kind of this. So we've got a thing called a place, and we can say A pathway is a place, a catchment is a sort of place, a subcatchment is a sort of place, a site is a sort of place, etc. So the conceptual data model shows on one sheet of paper what is the information that our organization has to deal with. What do we need to know about? What aspects of the context are important to us? So you can see from a strategic point of view, it's very important. You don't have to draw the diagram like this. This is another way of drawing. This is basically the same diagram. This is another version of the diagram that I drew for the same client. But in this version, it's using a different data modeling convention called object role modeling. And in this version, you can also show the attributes. You can show the attributes in exactly the same way that you show the entities. So it's very, very informal, this diagram. There are things on this diagram that normally would be described. So we've got depth there, for example. That would normally be an attribute of an entity, but I've chosen in this diagram to show it just as an object on the same level as everything else. So what's that is useful for is for capturing simply what your stakeholders think about the world, how your stakeholders see the world. And you're going to find out that by doing workshops, by talking to them, by listening to them and getting them to participate in identifying what other things the organization needs to know about. So you can put sticky notes on the wall. You will find that people will put things on the wall that shouldn't be there, but that's fine. They can still put them there, and you can transform them into an ORM model and then into a more structured conceptual data model. Another technique that is mentioned in the BABOK guide is the concept model. And it's described as a separate technique, but it's really the same thing. It's just that there are no boxes drawn on the diagram, but there are words which are joined together with lines. And when you look at it, it feels more intuitive, it feels more informal, it feels more like something that an ordinary person, not a business analyst or a systems analyst, an ordinary person might draw on the board to show the relationships between concepts. I find concept models very, very useful, but they serve a very, very similar purpose to conceptual data models. Some people say that the term conceptual data model is wrong. It's a mistake. It's a misnomer. Because a conceptual data model that isn't really modeling data, because it's not about the real world. It's about the concepts that people have in their heads. It's their idea of the world rather than the world itself. When I was working for this client doing this diagram, I actually created a document that describes that model, but in the same document, I had a table like this. And there's one row in the table describing each of the entities in the diagram. So you could call this a data dictionary, or you could call it a glossary. I really don't think there's a big difference between those two things. If I just zoom in there, in the first column we've got the name of the thing. In the next column we say what is the meaning of that thing, and it's very clearly and specifically defined. It's formally defined, if you like. And then the other columns tell you further information about the relationship of that entity with other entities, the different subtypes of that entity, and also, in this particular document, some information about data standards, which isn't always relevant. It was relevant for this particular project. Here's an example of a logical data model. So in between a conceptual model and a physical model, you can see it looks very, very similar. This is actually the data model that I created for the web platform for the IIBA UK chapter. So my company built the public-facing website and the administration platform for IIBA UK chapter. So this was converted into the database. It serves as documentation for the system. And one occasion when that was very, very useful was when we had to change the way that the system works. We had to enhance the system. We wanted to change something about the way that we were taking subscriptions, recurring payments. We were using Stripe, the payment provider. We were using their functionality to do recurring payments, but we decided we needed to manage that within our own application instead. So I wrote a very simple document describing the issue. And here on the left is a fragment of the logical data model for our system. We've got an entity called person, and each person can carry out many transactions. And there's a list of attributes associated with each entity. Here on the right is my logical data model that I've reverse engineered of the way that Stripe works. And there they have a thing called a customer, a thing called a card, a thing called a payment, a thing called an invoice, a subscription, and a plan. And when you understand how the entities fit together in one application, and you understand how they fit together in the other application, that tells you how difficult is it going to be to integrate these two systems together. What's going to be involved in integrating these two systems together? Very, very helpful way of getting started on the work. Here's another completely different application of a data model, and this is for designing the user interface for a system. So I use a conceptual data model in order to help design user interfaces for software applications, because when you look at how the concepts fit together, that tells you how is the user thinking about this application, how is the user thinking about the tasks that they have to carry out, and therefore what is the structure of the mental model that the user has. And the user's mental model needs to map closely onto the designer's model that is embodied in the appearance of the user interface. So these models are practically useful. They're practically useful in many different ways. And if you were frightened of using data models before today, then I hope you won't be after today. So that's all I wanted to say. Thank you very much for listening.
Intanto grazie per questi esempi, perché per chi sta studiando per le certificazioni, avere esempi pratici sulle varie tecniche, si trova qualcosa nel BABOK, ma avere anche altri esempi che arrivano dai progetti reali è veramente utile. Questa era la prima cosa, quindi grazie per questo materiale che ci fa da esempi per chi studia. L'altra cosa che volevo dire è che avevamo parlato all'inizio con Luigi Buglione di approfondire il tema ricerca, requisiti sulle varie categorie business, stakeholder, solution e transition legate alle misure. Ecco, secondo me ci dovrebbe essere anche una terza dimensione che dovrebbe far parte di questa ricerca, che sono proprio i dati, perché requisiti, dati e misure ci permettono, secondo me, di descrivere completamente tutto il flusso dal livello alto, che sono i business, fino al livello più basso. Quindi se facciamo partire questo progetto di ricerca, mi piacerebbe averti a bordo su tutta questa parte dati da esplorare, come collegare requisiti e misure. Vedo nel frattempo che sono arrivate le domande. Come pensi, why do you think these techniques evolved with the advent of data lakes?
Yeah, that's a good question. I think these sort of advances in data technology they make things look different, but I'm not sure if they really are that different. I mean, for example, with a data warehouse, people use different terminology, but actually when you look at what you're doing the same thing. The data models are just as applicable in exactly the same way. It's just that the data model for a data warehouse looks a bit different because the shape of it's different, because it's mostly a read-only database. It's a database that's designed for well, for reporting, for business intelligence. So you're storing denormalized data. I'm not going to explain what I mean by denormalized data, but so it looks different. So I think the same is true about data lakes. Really, it's all data. It's all related in the same way. It may not be in a relational database, but it's the same.
Now, be quick, Nick. Why not using user stories, or I think it's use cases?
Well, user stories are about functionality, and data is about data. Having said that, you can use user stories or something called data stories to describe how you might want to design a data warehouse. And that's a great technique. I've got a very good book about that somewhere. It's called Agile Data Warehouse Design. It talks about data stories. It's basically using examples to specify your data.
Marina is asking about interface models. How stakeholder can understand them? It is not easy. Do you use prototype or those diagrams? Yeah,
no, I should have made that clear. No, I wouldn't show that to a stakeholder. No. So yeah, no prototype. It's to help the designers design prototypes.
Last question for Nick. What software did you use to make those models shown?
Many different things. Visio, a drawing package that I used to use, whose name I can't remember. Sometimes I use the drawing tools, the data modeling tools that come with database software. So for example, SQL Server Enterprise Manager, Microsoft Access, the MySQL database management system has got an application that draws data models for it. You can use anything. I like Miro. Actually, Miro is I like for drawing any kind of diagram, really.
They're also asking about Sparks.
Yes, I'm not sure if any of the ones I showed today was drawn with Sparks Enterprise Architect, but yeah, I have used that. Yeah.
Okay.
Yeah, it's okay.
Thanks a lot. Thanks a lot, Nick. Thank you very much.
My pleasure.